So we're on day 11, our second review day for the test. Only homework is to study for the test. No warm-up, we're just going to go through the homework answers. So based on our proof statement, if we're seeing sides multiplying, we want to think, okay, this is a similar triangle proof. After I do my similar triangle proof, I'll just have those two additional steps. So start out, identify your triangles. We got AB. Well, there's only one triangle that has AB as a side. That would be ABP. So ABP has AB as a side and BP as a side. So that means BR and QB must be sides in the other triangle. That means we've got BRQ there. So we've got that little one on the bottom and then the top one. So from our givens, we have parallelogram. So we can do parallelogram implies opposite sides parallel. Then do parallel lines implies congruent alternate interior angles. I numbered them 1 and 2 and 3 and 4 to get them congruent. You could have also done just one pair of them and done a vertical angles as well. So our triangles are similar by angle similarity postulate. Make sure you have them matched up correctly. A should be in the same spot as Q, the B is in the same spot, the P and the R in the same spot. After that, we always do similar triangles imply proportional sides. Make sure the ones you want multiplying are diagonal from each other. So AB and BR should be diagonal from each other. QB and BP should be diagonal. And then our proof statement and our reason is product of the means equals product of the extremes. Pretty standard, similar triangle proof there. Next one, we have same picture, but we have different sides. So start out, we have PQ. Well, PQ is a side in two triangles. Actually, three triangles. So we got to move on. CB. CB is only a side in one triangle. It is in CBR. And when I say a side, it's got to be the entire side in the triangle. So CBR has CB and RC in it. And then the leftovers are PQ and QB. So then we're doing PBQ as the other one. So those are our two triangles. This proof should be really similar now to what we did in the last one. We're going to do parallelogram implies opposite sides parallel, but this time we want RC and QP to be parallel. Do your parallel lines implies congruent alternate interior angles. You got your two sets of congruent angles in your zigzag. From there, we got our angle similarity postulate. In your statement, make sure you're doing similar, not congruent. C and Q should be in the same spot. The B's in the same spot, and then R and P in the same spot. Similar triangles implies proportional sides. Make sure your ones you're multiplying are diagonal from each other. And then your product of the means equals product of the extremes for your proof statement. In 3, we've got the same picture, different letters. We got QR to start out. Well, QR is a side in 3 different triangles, so we'll move on. RS. RS is a side in only one triangle, in triangle RSP. Triangle RSP has RS and SP as sides, so that means QR and PQ make up the other one. So basically, the diagonal RP is splitting the two triangles there. We got RSP and RQP. Well, it's going to be pretty similar. The only difference is we've got to use our zigzag for both sets of parallel lines here. So we're going to have to do when we do implies opposite sides parallel, we'll have both sets in step 2 there. And then your proof is pretty similar to what we had on the others. So I'll pause here for like 30 seconds so you can check each of those. If you need more time, just pause the video if you need more time to copy down. All right, so we're going to start on page 64. We're going to do last class we did the construction and proof review ones. We're going to do the other review ones today. So we'll start on page 64 and we'll look at number 1. So they tell us the triangles are similar. So the two things we know if they're similar, we know all the corresponding angles are congruent and we know the sides are proportional. So let's maybe start by finding X. X matches up with 6. Now for our other sides, X came from the right-hand triangle. So we'll start with something from the right-hand triangle. We want to make sure we have no more variables. So we would want to do 12 over 8. That guarantees no more variables. Cross multiplying will give us 8x equals 72. And when you divide by 8, you get x equals 9. What I'd like you to do is see if you can set up a proportion now, solve for y. Then a box should pop up to allow you to put in what your answer is. So we should have had something like y over 4 equals 12 over 8. Getting 8y is equal to 48. And when you divide by 8, you should have got y equals 6. Next one, we've got similar quadrilaterals there. BC is x plus 1, so let's label that. DC is 9. QR is x minus 1. And RS is 6. Quadrilaterals, when they're similar, same idea. The corresponding angles are congruent. The corresponding sides are proportional. So let's take like the QR, x minus 1, and set it over what it matches up with, the x plus 1. And then we would have 6 over 9. When we cross multiply, we got to be careful because that 9 and that 6 will have to apply to both the parts. So we'll have to distribute through. So we're going to get 9x minus 9 equals 6x plus 6. Maybe we'll subtract the 6x over, and that'll give us 3x minus 9 equals 6. We'll add the 9 over. I'm going to move over here. That'll give us 3x equals 15. And to finish off, divide by 3, and you get x equals 5. Remember, in this course, always reread the question, see if you need to sub it back in or not. When we go up, it says it just wants us to find the value of x, so we're in good shape. Moving on to number 3, we want to know whether they're similar or not. Our similarity reasons, we have side, 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 similarity theorem, side, angle, side, similarity theorem, and angle, angle, similarity postulate. So here we don't have any angles, so we want to check our sides. So we've got 6 divided by 3 gives us 2. 8 divided by 4 gives us 2. And we're getting that from the corresponding sides. 10 divided by 5 equals 2. All those ratios are the same, so we would say yes, they are similar by our side, side, side similarity theorem. When you're doing similarity, the S's mean the sides are proportional, not that they are congruent. Well, let's take a look at this next one. We've got angles here. We don't have any sides. So the only possibility is to try and show that there's angle, angle. Well, 80 and 40 gives you 120, so this would have to be 60. So in our green triangle, notice there's an 80 and a 60. In our blue triangle, notice there's an 80 and a 60. So those do have two sets of angles, so we can say yes, they're similar by the angle-angle similarity postulate. That's the one that we use in our proofs all the time. So in this one, we don't have 3 sets of sides labeled, so we can't do side, side, side similarity theorem. We have sides, and notice they're sharing an angle. So we need to be careful when we match our sides. So in the small triangle, 3 is the little side. In the big triangle, the littler side would be the 6, the 4 and the 2 together. So that gives us a half. In the small triangle, the big side is 4. In the big triangle, the big side is the 3 and 5 together, 8. That gives us a half. So we've got the angle in between is congruent. The sets of sides on either side are proportional. So this would be a yes by the side, angle, side similarity theorem. In our next one, we don't have any sides, so the only thing we can possibly work with is angles. So we have 70 and 30 is 100, meaning that this has to be 80. If that's 70 and 81, that means that this one would have to be 29 degrees to equal 180. Well, we only have one set of congruent angles, so that's not enough, so this one would be a no. We've got a set of congruent angles. So it looks like the one we want to attempt here is side angle side similarity theorem. So let's do the 6 divided by the 12. That gives us a half. But then 4 divided by 9, that doesn't reduce at all. That's not a half. So therefore, that set of sides is not proportional. So therefore, this one's a no. So we've got the 60s here, and then we've got sides. So we probably want to be targeting side angle side similarity. Well, in this triangle, the small one's 16. In the other triangle, the smaller of the two sides is 24. So let's do 16 over 24. We can divide those both by 8 to get 2/3. Or you could just stick it in your calculator, and your calculator would tell you it's 2/3. In the one I put the blue dot in, the bigger side is 24. And the one I put the black dot in, the bigger side is 36. If you divide those both by 12 or just put it in your calculator, you get 2/3. So on either side of the angle, the sides are proportional. So this one would be a yes by our side angle side similarity theorem. All right, moving on to 4. 10-foot ramp is used to load freight on a truck. So there's our truck. There's our 10-foot ramp. A point 4 feet from the bottom of the ramp is 2 feet above the ground. So here's the bottom of our ramp. So let's pick a point here, and we'll label that length as 4. And that's 2 feet from the bottom of the ground, they're saying. So to make our picture a little bigger, what we know so far is that is 4, that's 2, and we know this is 10. And this should be a right angle in each of these because we are going straight up. So we want to know how far above the ground is the end of the ramp, so let's call that x. So we could do x over 2, and then go back to the big triangle would be 10 over 4. If we cross multiply, we get 4x equals 20. Divide both sides by 4 using opposite operations, and we get x equals 5. That's what we wanted to find. It's a word problem though, so think about units. We would have feet. So 5 feet is our answer. Moving over to 5. We've got our proportions here that we want to work with. So we have AB is equal to 16. DB is 4. And CB is X. So, red triangle. We're going to have 4 and X. Blue triangle, if we orient it the same way, like tip it to its right, we don't know anything it looks like. Green triangle, if we orient it the same way, The 16 was the hypotenuse, and that shorter side was the x. So it looks like we want to do our red and our green here, so we'll just set up our proportion. X in the red over 16 is equal to 4 in the red over x. X times x is x squared. 4 times 16 is 64. And when we take our square root, x is just 8. All right, next one, everything's labeled for us. So we'll call this one the green triangle. And x, by the way, is not labeling the angle. It's labeling that bottom side. So for this one, we've got x and 8 are the things we know. For that one, if we tip it to the right, so it's oriented the same, we would have 8 down here and then 16 here. And if we took the big triangle and oriented it the same way, the hypotenuse would be 16 plus x. And then the other two sides, we don't have anything labeled. So it looks like in order to find x, we would want to work with the green and the blue. The 8 in the green over the 16 in the blue should be equal to the x in the green over the 8 in the blue. Cross multiply, we'll get 64 equals 16x. Divide both sides by 16, and we'll get 4 for x. All right, next one's everything's labeled again. So I'm going to call this one the red triangle. So if we tip that to the right to orient it, 4 is now down here, x is there. We'll call this our green triangle, and we'll kind of have to spin it that way to get the short side there to match up. So this is x. This is now 5. And then our big triangle, we'll have to spin it and flip it to get it oriented the same way. So our short side there has nothing. Our long leg has nothing. And the hypotenuse is 4 plus 5, so we have 9. So it looks like we're going to have to work with our red and green triangles. We'll have x in the red over 5 in the green is equal to 4 in the red over x in the green. When we cross multiply, we'll have x squared is equal to 20. We'll take the square root of both sides, and we'll have x equals square root of 20. If we type in square root of 20, that doesn't give us anything nice. So we would want to think our menu number factor. So when we do menu number factor, we would get 2, 2, and 5. There's a set of 2's, one goes out front. So x would just be 2 square root of 5. One more of these. We'll call this one the red triangle. And we'll just keep it oriented the way it is. That might be easiest. So that's 4, that's x. This one will make the green triangle. So if we tip that to the left so it's oriented the same way, we now have that this is 12. And looks like that's all that we would know for that one. And then if we do the big triangle and orient it the same way so the little side's on the bottom and we're pointing to the left, our hypotenuse across from the right angle is the 4 plus 12, which is 16, and the little side in that one is x. So it looks like for this one, we're going to have to use the red and the blue. So x in the red matches 16 in the blue. 4 in the red matches x in the blue. So we cross multiply, we get x squared equals 64, which we've seen that before. When we do the square root, we just get x equals 8. Moving on to 9, we've got parallel lines. So when you have parallel lines, you have congruent corresponding angles. And then you've also got a reflexive angle there. So therefore, we know these triangles are similar. Because they are similar, we can then do a proportion for the sides. EC is 3 times AD. So we would want to call AD X, and then EC is 3 times that, so we would call it 3X. We can either do proportional sides, or we can do our side splitter theorem. Because when you have parallel lines, the sides are split up proportionally. If we did the side splitter, we would do something like x over 8, getting the same spots to match up, is equal to 6 over 3x. If we cross multiply and solve this, we would get 3x squared equals 48. If we do divide by 3, we'd get x squared equals 16. And then take the square root, we'd get x equals 4. See what they wanted us to find? They wanted us to find AD, and that's what we called x, so we're in good shape. The other way you could have approached this one if you thought small triangle and big triangle. Small triangle has an x. It matches with the big triangle, we would have x plus 6. Small triangle has an 8. Big triangle would have 8 plus 3x. If you distribute this, we'd have 8x plus 48 equals 8x plus 3x squared when we distribute. Well, notice when you subtract the 8x's, they wipe out. And this now, 48 equals 3x squared, ends up the same as where we were at that step there. So you'll eventually get the same answers in the end. Moving to the next page with 10, we got parallel lines again. So parallel lines have congruent corresponding angles. We also got a reflexive here. So we know these sets of triangles are similar. So we can again either do the sides proportional or use our side splitter theorem because we have parallel. So we'll show you both ways. There's 8. We have AB, so this whole thing is 12, meaning this is 4. We have EC is 5, and we want to find AE, which we'll call X. First, let's do it if we did it the side splitter way. X matches in the same spot as 8. 5 matches in the same spot as 4. When we cross multiply, we would get 4x equals 40. And if we divide by 4, we'd get x equals 10. We were looking for AE, and that's what we called x, so we would be all set. If you wanted to do the similar triangles, take 8 from the small triangle, match it with 12 from the big triangle. Take x from the small triangle, match it with x plus 5 from the big triangle. When you cross multiply, you'll get 12x equals, and we'd have to distribute the 8 through, so we'd get 8x plus 40. Subtract your 8x over, and we get 4x equals 40. And notice that's the same spot as right there, so you would end up with the same answer in the end. (11) and 12, we got a whole bunch of parallel lines, so we'll do some side splitter. They tell us FI is 30. So here to here is 30. And we want to find FG, so we'll call that X. So let's start with the X. That matches with 2. Then we'll take the 30 they told us. That had 3 sections together, so that's got to match with those 3 sections. If we add those up, that's going to give us 10. Now just cross multiply, you get 10x equals 60. And when you divide by 10, you get x equals 6. X represented FG, and that's what we wanted to find. We switch up what they give us in the next one. HJ is 27. So from here to here is 27. We want to find HI, so we'll call that X. So X matches with the 5. 27 would match with these together. So 5 and 4 gives us 9. 9x equals, a way to do 27 times 5 in your head, think of 27 as 20 plus 7. 5 times 20 gives you 100. 5 times 7 gives you 35, and then add them together to get 135. When we then divide by 9, we'll just get 15, and x represented HI, which is what we wanted to find. So the next several we already did yesterday. We did our proofs, we did our constructions. So we're going to go all the way ahead to page 69 next. And we're going to look at number 19. So we want the image of negative 3x plus 2 after each of these dilations. So let's sketch what negative 3x plus 2 would look like. So we'd start at positive 2, and we'd go down 3 and right 1 over and over again. And then we'll do the reverse as we head back. If you have your straight edge, go ahead and connect those points with your straight edge. So that's our original y equals negative 3x plus 2. Remember, when we dilate, if the center of dilation is on the line, it creates the exact same line. If the center of dilation is not on the line, it creates a parallel line. So let's just spot check these centers of dilation first. 0, 0, not on the line. Okay, that's going to take a little bit of work. Negative 1, 5. Negative 1, 5 is on the line. Okay, so that equation is just going to be the same. So for B, we can just write the same equation. For the next one, we've got 3, 4. 3, 4 would be up here. That's not on the line. So that's going to create a parallel line. So what we want to do is we want to dilate one of the points and then just re-put in our slope. So we want to be 4 times as far from 0, 0. So let's take this point right here and compare it from 0, 0. From 0, 0, we went right 1, down 1. Well, we now want to be 4 times that. So from 0, 0, we're going to go right 4 and down 4. And now, because we know it goes through this point, and because we know it creates a parallel line, the slope would be the same. So just go down 3 and right 1 as many times as you can, and then do the reverse. So this is going to be our new line. We know it's got the same slope, y equals negative 3x, and then just see where we're crossing the y-intercept. 2, 4, 6, 8, so it's negative 3x plus 8. So you just dilate one of your points and then follow the same slope because they will be parallel. C is going to be parallel as well because we identified the center of dilation was not on the line. 3, 4 is right here. And remember, we got to do it from the black line, the original line. We want it to be twice as far away. Well, from our center of dilation, down 2 and left 3. So we need twice that. So we want to go down 4 and left 3. So we've got to do another set of down 2 and left 3, so that should put us here. We'll now just do our slope. Down 3 over and right 1 a bunch of times, and then carry that back the other way. And this will give us our one for part C. Notice where it crosses the y-axis. It crosses at -9. So our equation for this one is just y equals -3x minus 9. So if the center of dilation is on the line you're dilating, just the same equation. If it's not, dilate one of the points and then remove with your slopes to help you find your y-intercept. Last one for this video, we'll look at number 20 on the next page. We have ACT, and we're going to dilate it with a center at 1, 2, and we're going to do a scale factor of 3. So let's just start with A. That's an easy one. A is 2 up from that point. If we multiply that by 3, that means we want to go 6 up. So 1, 2, 3, 4, 5, 6. A prime will be right here. To get to T, we go down 1, right 3. If we do 3 times that, we now want to go down 3 and right 9. So here's where T prime would be. If we go to C, we're going down 2 and right 3. Sorry, left 3. Down 2 and left 3. If we multiply that by 3, we're going to go down 6 and left 9. So that's where C prime will be. And then use your straight edge to connect those points. And that would be our image. Now just something to compare it to the last question. Notice our center of dilation was not on any of the sides. So when we dilated the figure, all the sides were now parallel to the original sides. All right, that's it for this review video. A good idea would be to go back on the review problems, cover up what we did the past 2 days, and see if you can now do them on your own. Have a great rest of your day. We'll have the test in class tomorrow. Remember, for the test, you're taking it during the period. Just open the test right up. You can use your notes on it because I'm not here. So you can use any notes you have from class on the test. No communicating with anyone else during the test, though. You must take it during the window of the class period and upload it by the end of the class period.